Welcome to the unit on if statements and expressions. This week we're going to start to build our toolkit out from just doing line by line code where we can kind of limit what we're doing, and we're going to really start getting into some of the powers of computing using a concept called branching based on either just straight values or even looking at variables themselves, building on what we did last week, and considering them and doing different things based on what they store. It's one of the real core things we do in computing. Pretty powerful concept. I've got a few slides here just to kind of illustrate it. They're not great slides. I apologize for that. If you recall kind of our model where we take an input and we do something with it and produce an output from our previous weeks where we did something, for example, maybe with a print function, and we have the user put hello into like a variable, and then we print that variable and it prints it to the screen. We can do similar things with what are called expressions and branching statements. The main branching statement in Python is called the if statement. And what it does is it evaluates what's called an expression. And I'll get into this in code in just a little bit. But what an expression does is it basically evaluates if something is true or false. What are examples of this? Well, we might take two values and two numbers. Let's say the numbers 2 and 4. So let's say the value 1 here in my little slide deck is 4, and we might say the value 2 contains 3. And what we might do is say, let me go ahead and get rid of this for a sec here. Just move it down here. What we might say is, does the expression, let me grab another text box here. Sorry, I'm not doing a very good job in PowerPoint here, but we'll get through this little bad text snafu here. What we can do is we can write what's called an expression. We can say if value 1 is greater than value 2, right? What this will do, this if statement basically says, take these things in this logical operator and tell me if this thing is true. And this reads just like it does in math. It's saying, is 4, the value held by value 1, is 4 greater than 3? And in this case, it would be true, right? Because 4 is a bit greater than 3. Or if we flip them around, we could do something like this, and then it would evaluate to false. That's the essence of expressions really in a nutshell. I'm going to actually duplicate this slide because I kind of like what I just did there. And I'll do a different thing with the end statement down here. So I'm just going to clean this up as I go. I apologize for doing that in real time here. So the idea of an and statement then, let's go ahead and put this back up here, is that we can also combine these things. So like we might do something in Python. Let's just grab a text box. I'll just copy this one, I guess. And we might say, instead of value 1 being 4, we might say something like, this is today's temperature. We might say, let's say it got a little chilly out today. Let's say today's temperature is 50. And I'm going to rename this. Let's call it temp. And let's say the hour is, let's say it's 8 o'clock outside, p.m., 8 o'clock p.m. And we wouldn't do this in code because we'd have to deal with strings and stuff, but for illustration purposes, we're gonna use this example. So what we might want to do is write something to the extent to say something if, again, we could use if the temperature, I'm going to try to capitalize it, is less than, let's say, 60, and the hour is past 8 p.m., or let's call it 7 p.m., just to illustrate here, we can say if this is true, and so basically it does it twice. It says, is this true? And is this true? And if both are true, then it will evaluate to true, right? And if one of them is false, let's say we change this to 70, and we say if temperature is less than 60, if the temperature which is set at 70 is less than 60, this is now false. So this whole thing would evaluate to false. So what we do with and is we can combine things. And there's different operators like this. I'm just introducing the topic here. You'll get into this in your reading, but I kind of want to show you the power of these things in a lecture format. And we'll get into just a little code here in a second. I think that's all of the slides I have. But I also did want to point out one other thing that you have available to you, which is this, where did I put that sucker? Oh, let's just turn that on right now. Sorry, I'm still kind of setting up this is the course as we go. I wrote this guy, which kind of goes through the different ands and ors and things like that, and tells you how they evaluate. These are called truth tables. These will be covered in your readings, and just like what we just did, it discusses several different options for combining this kind of logic. I'm not going to jump into this too much in the lecture here because I want to keep it brief, and I think it'll be covered, but do let me know if you have questions about that. Getting back to the assignment, though, and a little more lecture material, we will have this homework this week. You might have seen this when I did the homework overview outright. You will basically be doing the PRIM model again, where we predict and run, basically play with some code, and I'll go over that in just a hot second. Investigate, where we take a look at things and kind of figure out what might break and might not break. It's building on it. And modify some code to do a few experimental tasks in the code environment. And then finally we'll do this kind of thing, where you're going to take some input and basically figure out the hour and to display an appropriate message. And we'll get into an example that does a very similar thing to this in our example. And lastly, just because we've moved away from Replit, I just want to remind, if I've left traces of Replit in there, make sure that you do turn in the code. And for the assignment down here, you could call this if statement assignment or week 3, whatever you want. It doesn't really matter to me as long as I know it's you and which assignment you're working on. So let's see if there's anything else I wanted to hit on these pages. I don't think so. Actually, that's not even, yeah. Okay, so I'm going to give a few more examples here, and then we'll go through the assignment stuff. Just clear this out. And I actually want to introduce a feature in Visual Studio Code as well. This is just a bunch of different bits of Python code I've written to illustrate here. But what you can do in Python is you can actually not run the whole file like we do when we do this. Like this actually won't make a lot of sense because all of these things are little files that I just wanted to put into one place. But like so, you'd get probably an error somewhere, right? Because I've left a lot of junk in here in this example. But what you can do is, for example, this is going to import what's called the math library, and we need this so we can do square roots in Python is the reason I've done that. So the idea is it takes the number 9, or a number, and assigns it to a variable called myNumber, and it figures the square root. The way I can execute just this code is highlight it, and I can either right click, and I can go run current file or current selection line in interactive window like this. Oops, sorry. Let's cancel out of that. I hate when that thing does that. Let's just cancel that, all that out. You can hit Control Enter, so let's make sure that just works with the maybe I hit the wrong thing, or Shift Enter. I'm sorry, Shift Enter. I don't know why that's wanting to launch over there. Okay, let's just use Shift Enter for today. I'll figure out why that's doing that in my window another time. But Shift Enter will basically send your command to a Python prompt, and if there's not, you can just close this if you want, and if there's not one, it will launch one for you like that. And then if you're getting tired of the redundancy, you can actually drop this down right here, not that one. You can drop this one right down here, and you can clear the terminal as well, which is quite nice for this kind of stuff. And I'll be doing that while I'm illustrating. Just wanted to let you know what I'm doing. I'm hitting Shift Enter when I do this to run different kinds of code. And it's a nice way to play with some code and experiment in the upcoming assignment. So why do we use if statements at all? Well, one is to extend a calculation, right? Let's say we either had a user input this number. We basically want to write a calculator. This works just fine. We import our math statement, run the thing, and we can see it imports math. It feeds the assignment of the variable 9, or the value 9 to the variable my number, and then it prints that out. And then finally, we get the output. This is the output, by the way. These three greater than signs are basically telling you this is what was input when you operate in this interactive mode like this. But as we know, we can't take square roots of negative numbers. So let's go ahead and try that. Let's go ahead and run that, and we get a value error from the math library, and it says you can't do that. It says a little more cryptically than that, as computers often do. So what we can do instead is we can use the if statement, and let's go ahead and introduce the syntax here. We can basically write an expression. This number and this value are compared with a greater than or equal to assignment operator, and you can look. We have all those in the book, and you should go through those either in that page I just showed you from Canvas, or you can the book or any Python lines. There's several of these. Greater than or equals. All of the things you would think would be there are there. So what we can do here is we can write this expression, and then what if will do here is it will say, if this thing is true, do this next thing. Now, this is a weird syntax that we're introducing right here. When we do branching or blocks, what we do in Python is we write a colon to say, okay, there's going to be a part of this code that executes based on this thing. And we'll see this in different syntaxes as we go. But for now, we need to write a colon, and then we need this indent. This indent is very important. It's usually 4 spaces, but they have to be the same in Python. In other languages, you'll use braces and things like that to tell the interpreter where things start and stop. But in Python, we don't. In Python, we use this indent. So when I run this, I'm going to run it just to kind of show you the difference. We'll demonstrate the code, and then we'll break down the code a little bit more. So when I run this, you can see we feed this thing through, and it runs, and it basically says, because we're -1 here, it does this part. It says this is not true, because we're -1 right now. So the number is not. This is not true. The number is not greater than 0. So it fails this, or it fails this, and it says, okay, this is the true part and this is the false part. So it goes down here and it explains, it does a nice user-friendly thing. It says, hey, silly, you can't do that. Now if I change this back to 9, we'll see the opposite happen, where we can fire this off and it does exactly what we would think, where we get 3 back out. So that's one, like the first justification is to basically do something based on what's going on in the program. And in this case, we get unexpected values, and we can do different things based on how we want to handle this condition right here. One thing I want you to be aware of, let's pretend we were rewriting this to say, I want to know if it's exactly the same. This syntax right here, you might recall from our variable assignment, is the assignment operator. This equal sign is saying if the, or I'm sorry, it's saying assign the number 9 to the variable number. If I wanted to actually compare these things, I would write it like this. This is important. So this means Are these things equal? This means assign this to this. I'm going to say that again because it's crucial, and somebody's going to make an error. And then if I call it out now, I can point to this video and say, this is what you need to study a little bit more. This equal sign, the single equal sign, assigns the number 9 in this case to the variable number. The double equal sign compares the value in number, in this case, to 0. And this is a test. So let's go ahead and try this. I'm going to change this. Actually, I'll just copy it because I want to use this code later. Let's go ahead and do this. And let's say print. Let's just make this a lot more simple. So right now, we're going to first take the number 9, assign it to the number variable, and we're going to compare number to 0. What do you expect happens? Exactly what we would think, not equal. Change this to 0. Guess what? Equal. Pretty straightforward, I know, little pedantic, but I really wanted to emphasize this is what's called an expression, and it's being evaluated by this if statement. If this passes, it's going to do this block of code, and we can actually have more than one line of code. What's a block of code? Great. I'm glad I kind of stumbled into that. I didn't think about it till just now. Print. You can do a lot. So the reason we indent this is because this basically becomes a little sub-program, if you will, that executes only if this happens. And it'll keep going until we come back out to the indent. So the indent says, do this stuff when this happens. And same thing can happen with the else statement. So we can see that, and we can see that both of those lines execute. Some other cases for if. Let's say we have an age variable. We do something like this. We might have a thing that says, you need to be 18 to use this program for some reason. Probably not the best example for a college setting, now that I think about it out loud. But let's say we've read this variable, we know it's a number, and we want to say, okay, if they're 18 or over, access granted, otherwise don't. Well, we can run that, and as you might suspect by now, that this will pass until we change this to like 15, and then we say the same thing. So similar to the math thing where we're handling different kinds of uses, but this is be more of a logic thing that we want our program to do something based on what we're seeing in the program in variables. And the really nice, like you could absolutely do this, right? Something like, make that comparison to constants. There's nothing wrong with that, but the nice thing about computers is we can use variables to change this out and start to modularize our code where we make it more reusable by having a placeholder for the age and plugging values into it from other places. This is a theme we'll expand upon as we study programming more and more, is this, again, this idea of taking an input, doing something with it, and producing an output. Well, it turns out that's all we're doing here, really, is we're taking an input to the if statement, which is this expression, and then the output is either this or this, depending on what this is. So it's our first kind of concept where we expand that. Just a couple more examples I wrote up here. I'm going to skip this one. It's kind of boring, actually, where we have a greeting like that might happen at the beginning of a program. But what we can do is, for example, we might have this little function, it's called. You can read it just like a program. You can, actually, I'll just get rid of that. We don't really need that. So I'm just going to unindent things, just back to normal, because of the way I wrote it quickly. We'll get to functions later. We'll explain what was going on there another time. And I'll just make this, we'll just make it print. Sorry, I left the code like that. That was a little much to read in week 3 probably. So what this is doing is it's taking from a part of Python called the datetime library. Don't need to really know what that is, but it gives us access to what the hour is right now. That's what this all comes back out to, and assigns it to a variable called the current hour. That's the upside of what we're doing here. And if I run this whole thing, we can see that because it is now 5:40 in the afternoon, it's basically saying, is this thing less than 6? And this is on a 24-hour clock. And it's saying, nope, it's not. So we don't say good morning. And it's saying, is it less than 12, but also, or greater than 12, but also less than 18? And it will say, no, that's not true either. So we're not saying good afternoon. And then it does this else statement. And the else statement basically catches everything that doesn't happen, and it will do something by default. So in this case, we get the good afternoon bit of code here. The elif is new to this block. And what this is doing is saying, first try this. And we have our expression here saying if the current hour is greater than 6 and less than 12, that's how to read that. It's shorthand. You could also write that like this if you wanted to make use our and statement. We could write it like that, probably a little clearer, and I'll go ahead and do that here as well. That's a shorthand. Those are the same thing. It's saying try this, and again, going back to our truth tables, both of these have to be true for this to be true. And then it says that failed. Same thing here, because it's actually, nope, it's actually, this would pass. We're not quite evening. If I lecture for a little more longer, and I hope I don't for your sake, then we'll get into good evening here, just as you would expect. So just a couple ways to move from a general greeting to something a little more user-friendly and dynamic. So you can see where we can start to implement some of our ideas in computers in if statements. So this week in the assignment, I actually have done this in the same file. This will be under support files when I repackage it here. I'll go ahead and save that. That actually is okay. We don't need that. So you might remember prim, preview. So let's go ahead and look at that. There's the preview instructions, which is basically telling us what we're going to do long term. And then we'll get into the predict part. So basically you're going to kind of go through what we think will happen here. And this is a great time to use that trick I just taught you. So you can go through this, and I won't uncomment this yet, but you can actually say, okay, I'm reading this as number equals 7. Thought of it. What's this going to do? Well, it's a guessing game, isn't it, right? So we can kind of play with that. Looks like I messed up an indent in there. I'll have to take a look at that. The other way you can, of course, do that is run our play. Let's go ahead and clear this out. Let's just kill that and run this. What did I do? How did I break it? I'll take a look at that and clean up the code. Apologies for that. There's something going on with my VS Code here. I don't know exactly what I did. This should work by my eye, but it's also late in the day. Examine this code and kind of try to figure out in your head what it's going to do, and then run it and see if it does the things that you would expect. And then what you can do if you want to run this other code is you can uncomment this. So what do I mean by comment? When there's two ways to write basically notes to yourself. That's why they're called comments in code. The first is this pound sign. Anything on a line that follows this pound sign will not execute. So you can write my name, you could write example code, whatever I want in there. The other way to do it, to block out a bunch of code at once, is to put 3 of these quotation marks around it. And I've done that here to disable this code, which is another handy byproduct of coding. You can basically say, I don't want to run this thing anymore. So what we can do to get this other part to run is we can actually just move this like that, and you can see it kind of makes it red like that. That's basically telling us this isn't going to run anymore. That's a hint that is telling us. It's basically considering this whole thing a string in this case, and it's saying ignore this. Let's see if this other one runs. I don't know what I'm doing wrong here. I apologize for that. There's something that happened here. I'll tell you what, let me relaunch. Let's close everything. Let's close all, close everything. Let's close all. And this is a good opportunity, of course, to let's just exit. And if you might recall from our earlier video, if you've downloaded the files as instructed and expanded them out somewhere into a folder, you can right-click on this and do show more options and launch the whole workspace with Open with Code, which is quite handy. Let's see if that cleaned up our code here under Predict. Let's go ahead and try that. So let's just try that. I do not know what's going on. I wonder if my interpreter got messed up. Anyway, we'll get that squared away in the code. I'll make sure that works before I send it out proper, but that's what you'll be doing here. And then we will go into the investigate, where you'll answer some questions about the code. And again, this is just kind of, in your own head. You don't have to submit this or anything. Do let me know, though, if you have questions. This is part of what we're introducing to kind of make it a little more interactive, even though I'm not sitting there with you while we're doing this. I'd love to be, but that's not what we're doing with this class. And then and there's instructions for all this, by the way, where you can go into the investigate instructions, the predict instructions, so on and so forth. And then finally, we'll play. This will give you some instructions to modify this to actually take two numbers or a third number, and add another if statement here. And then finally, we'll get to our assignment itself, where you will basically be doing the instructions for the overall assignment, which again, you can use preview for to make it a little prettier, and you'll be fulfilling this requirement, which is also, of course, in the assignment itself here. So that's what you'll be doing, is writing if statements to basically do this, and then you'll go ahead and name it appropriately, something like this, where we might call it assignment 3, and then you'll button that up and submit it to Canvas, and I'll grade it, and we'll all learn some great things together. So apologies for the code demo there. Try to get that squared away and figure out what that is. I might post a little supplement video later tonight when I figure out what's going on with Visual Studio Code. My computer's been a little finicky here. This worked at home this morning, but not here. So anyway, that's the if and expression lecture for this week. Let me know if there's any questions. Use the discussion boards. We'll have one both for the weekly assignment and how this adds into the final, and then also a general support one. Let me know what's going on there, and we'll get to it. Thanks.